This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is the definition of the inverse of a function. Let f and g be two functions such that f of g of x equals x for every x in the domain of g, and that's because we have g of x here in the inner parentheses, and g of f of x equals x for every x in the domain of f. And just remember, we can write f of g of x as f of g of x. So that's another way to write that. And we can write g of f of x as g of f of x, because this is composition of functions, so that means the same thing. But if this is true, then the function g is called the inverse of the function f, and we denote it by f with this little -1, which is not an exponent. F is not a variable, f is a function, and we read this as f inverse. So make sure you understand when you see this f with a little -1, it is not 1 over f. It means f inverse. Thus, instead of writing f and g, we could say f of f inverse of x equals x and f inverse of f of x equals f. The domain of f is in the range of g. Remember, you could switch the x and y's in all the ordered pairs, and the domain of g is the range of f. And here's the other notation at the bottom. So these two things mean the same thing, right? And these two things mean the same thing. So here's what's really going on. If you have two functions that are inverses, that means they undo what the other function does. So if you imagine you have this like function machine, that does something, so you put something in it, let's call it x, it pops out f of x, right? That's what happens when you put it in the f machine. Now you put f of x in the f inverse machine and x pops out. So whatever you put in, it scrambles around and does some stuff, and then you undo all that stuff and the same thing comes out. So here's an example. F of x equals x minus 2 and g of x equals x plus 2. So let's compute f of g of x. So I want to do f of, now g of x over here is x plus 2, so I'm plugging that in. And now we look at what f of x is. F of x is x minus 2. So in place of x, we're putting x plus 2. So we're putting x plus 2. You do not need parentheses, but I want you to see what I'm substituting in for x right here. And notice what you get. You get x. Let's do it over here. So I'm doing g of, what's f of x? Oh, it's x minus 2. And so now we're going to plug in x minus 2 in for this x in the g function. So I'm putting in x minus 2, that's in place of x, and I'm adding 2, so my answer is x. Since this happened, this means that f and g are inverses of each other. Now let's see if that makes sense. F says you take a number and subtract 2. G says you take a number and add 2. Does that make sense that you're reversing something? So in other words, if you take a number and you subtract 2, and then the next step is to add 2, you'll get back to what you started from. Similarly, if you take a number and add 2, and then the next step is to subtract 2 from that x, or you get right back to where you're going. So this means that these are actually inverses. So I could have written f of x equals x minus 2 and f inverse of x equals x plus 2. I understand that these are inverses. Now this works for any number you plug in. So let's try another one. Same problem basically. F of x, did I say that was plus or minus 2? I said that was minus 2. Okay. That was minus 2, and I had g of x equals x plus 2. What if I put in f of, 5? I'm sorry, f of g of 5. And what if I'm going to do g of f of 5? So instead of plugging in x, I'm plugging in 5 into both functions. I'm doing this composition. So what's g of 5? So we go over here, we put in 5 for x. G of 5 is 5 plus 2. That's 7. And now we're plugging in f of 7, right, into the f function. So what's 7 minus 2? You get 5. So look what happened. I plugged in 5, and out pops 5. Let's see if that happens over here. F of 5, I go over to this function. If I put in 5 for x, I get 5 minus 2, that's 3. And then what's g of 3? Go back to the g function, plug in 3. 3 plus 2 is 5. So when I put in my 5, right, if I do the function and then I do the inverse function, whatever I put in comes out. So what do you think f of g of negative 9 will equal? Just think about that without doing the computations. What is, if f and g are inverses of each other, negative 9 pops out. What is g of f of 3x minus 8 going to equal? G and f are inverses, so if you scramble, you do f of 3x minus 8, whatever you get, once you go back and then plug that into the inverse function, the same thing you put in should pop out. Let's verify that, because that's a little bit harder to do in your head. So remember, f of x is x minus 2. I'm going to write that over here. And g of x was x plus 2. We have to know what functions they are. So let's do this. G of f of 3x minus 8. Okay, so that means g of what? Well, what do I do? I have to put in 3x minus 8 into f of x. So f of 3x minus 8, I'm putting in 3x minus 8 in for x, right? And subtracting 2. So in other words, I haven't computed this completely yet, right? But right here, that's my f of 3x minus 8. So let's just do, add the like terms here. That's 3x minus 10. So this 3x minus 10 is f of 3x minus 8. Now we're going to plug that 3x minus 10 in for x into the g function. And the g function says it's x plus 2. So I'm replacing x with 3x minus 10. And I'm adding 2. So that gives me 3x minus 8. So, did work out. Plopped in 3x minus 8. We did one function, then we did the inverse function, and out plops the 3x minus 8. That will happen no matter what you put in when you're working with inverse functions. So let's do a problem where we're trying to find out if something is an inverse function. So let's do this problem. Determine if f and g are inverses of each other, if f of x is 2x minus 3 and g of x is 1/2 x plus 3. So we want to find out if f of g of x is going to be x, and remember that means, f of g of x. Doesn't matter which notation you use, right? Because those mean the same thing. So let's put in what g of x is. G of x is 1/2 x plus 3. So we're going to replace g of x with 1/2 x plus 3. And now I have to plug in 1/2 x plus 3 into x in the f of x function. So that's 2 times x. But in this case, what am I replacing that x with? 1/2 x plus 3. So there's 2 times the x. Oh, and then minus 3. So let's see. We're going to do the distributive property. 2 times 1/2 x is x, plus 2 times 3 is 3, minus 3. So we get x plus 3. So when I plugged in x, right, and I did the two inverses, I got x plus 3. So these are not inverses because I should have gotten x for my answer. So the answer is no, they're not inverses. Let's see what the, we'll figure out what the inverse of these of f of x is on the next video. And then we will show that when we put f of g of x, we do come out and just get x if we do have two inverses. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.